welcome to Neuroscience AF, where we briefly discuss cool science topics with Andrew and Fen. Chances are, when I say amphetamines, you might think of methamphetamine, but the reality is, amphetamines aren't just legal drugs. Adderall, for example, is an amphetamine, but is prescribed by doctors all the time for ADHD. Amphetamines are all around us, but how do they work? In order to help with focus and attention, amphetamines must alter our brain chemistry. No, not like that chemistry. More like this crazy chemistry. Wow! This is a single synapse in the brain, filled with tons and tons of tiny proteins. We've got trillions of these synapses in our brains, all parts of our billions of neurons. To alter brain chemistry, we need to change the balance of proteins here at the synapse. As you can imagine, changing the balance of proteins is very difficult and delicate. Amphetamines act at the tiny synapses in our brain to artificially increase dopamine levels. They increase its production and prevent its breakdown. As a result, dopamine builds up until the neuron can't hold it anymore. At this point, it expels dopamine into the extracellular space, where it will constantly signal to the other neurons. As we learn more about the function of amphetamines and how exactly they alter this balance of proteins, some doctors and researchers think that using and abusing amphetamines might disrupt this delicate balance in a bad way, making you more susceptible to Parkinson's disease. Not only do amphetamines alter dopaminergic signaling, but they also affect the neurotransmitter glutamate. It removes reuptake transporters from the presynaptic neuron and increases the number of glutamate receptors on the postsynaptic neuron. As a result, glutamate accumulates in the synaptic cleft. Because the number of glutamate receptors are increased as well, the glutamate in the synapse will bind to the receptors and excite the postsynaptic neuron. Without anywhere to go, the glutamate keeps exciting the neuron. In fact, it gets so excited that it just can't take it anymore and the neuron actually dies. This is called excitotoxicity. If we zoom out, these glutamatergic neurons can be signaling to dopaminergic neurons in the substantia nigra. This brain region is responsible for initiating movement, so if it's overloaded with glutamate and dies, then the patient can no longer move. Death of the substantia nigra is the defining factor of Parkinson's disease. This finding raises important questions about the long-term safety of amphetamines. It's likely that the dose of Adderall physicians prescribe to ADHD patients is safe, but people abusing the drug could suffer some severe consequences in the future. As for now, the verdict is still out on whether amphetamines increase your risk of Parkinson's. Until we find out more information, I'd recommend that you avoid using them if you don't have to. Thanks for watching Neuroscience AF. Cool science with Andrew and Fen. Make sure to stop by and watch next video.